Consider for a moment the silence of the deep. Not the ocean, but the true deep, the vacuum between the stars. We live our lives here on Earth, distracted by the noise of politics, the notifications on our phones, and the immediate concerns of our daily economy. But while we are busy looking down at our screens, something ancient has been drifting through the dark for millions of years, silently falling toward us. It is a traveler from the frozen nursery of our solar system, a witness to the birth of the sun, and right now it is performing a swan song in our skies. I am talking, of course, about Comet 2025 R2, known to us as SWAN. Now, you might ask me, Avi, why should I care about a ball of ice and dust? Is it an alien spacecraft? Is it another Oumuamua? And while my research into interstellar objects often leads me to ask controversial questions about technology and artificial origins, sometimes nature itself provides a spectacle that is purely, beautifully natural, yet no less profound. To see a comet is to see the mechanism of the solar system in action. It is to witness the fragility of existence. But here is the challenge. We have lost our connection to the sky. We have drowned it out with LEDs and streetlights. So, in the spirit of the Galileo project, where we believe in gathering evidence and looking through the telescope rather than arguing theoretical possibilities, I want to teach you how to observe this object. I want to tell you not just where to look, but how to see. Because seeing is not just about photons hitting the retina. It is about the brain understanding what is there. When I was a boy in Israel, growing up on a farm, I used to collect eggs in the afternoon and read philosophy books in the evening. I learned early on that nature does not give up its secrets easily. You have to be patient, you have to be willing to be uncomfortable, and you have to understand the context of what you are seeing. This comet, SWAN, is a long period comet. Think about what that means. The last time this object might have been anywhere near the sun, if ever human beings did not exist, it has spent eons in the Oort cloud, that vast spherical shell of icy debris surrounding our solar system, drifting in a gravitational slumber. Something nudged it. A passing star, perhaps, or the galactic tide, and it began a long, slow fall toward the sun. As it approaches the inner solar system, something magical happens. This is basic physics, but it is poetic physics. The sun's heat strikes the surface of this frozen wanderer. The ice doesn't melt into water. In the vacuum of space, liquid cannot exist like that. It sublimates. It turns directly from solid to gas. This gas expands explosively, dragging dust particles with it, creating a massive glowing atmosphere around the nucleus called the coma. This is what you are looking for. You aren't seeing the rock. The nucleus is tiny, just a few miles across. You are seeing the cloud, which can be larger than the planet Jupiter. So, how do we find it? If you are listening to me from the United States, from Canada, or anywhere here in the Northern Hemisphere, your window of opportunity is driven by the geometry of the sunrise. This is an early morning affair. I know getting up before dawn is not something most Americans want to do unless they're going to the gym or catching a flight. But I urge you to try this. You need to look east. The comet is racing toward the sun, which means it rises just before the sun does. You want to be out there about 60 to 90 minutes before sunrise. This is a delicate balance, a window of time that astronomers call nautical twilight. If you look too early, the comet is too low in the haze of the horizon. If you look too late, the blue scattering of sunlight in the atmosphere, the very thing that gives us our blue sky, will wash out the faint glow of the comet. For my friends in the Southern Hemisphere, in Australia, South America, Southern Africa, the geometry favors you in the evening. You should look west after sunset as the twilight fades. You have a better angle on the ion tail, that the stream of charged particles being blown away by the solar wind. But let us talk about the reality of observation. We live in an era of hype. You see headlines on the internet promising a spectacular light show or a blazing sword in the sky. I must manage your expectations. Science requires honesty, not sensationalism. Unless a dramatic outburst occurs, Comet SWAN will not look like the photographs you see from the Hubble Space Telescope. To the naked eye, under a standard suburban sky, it might be invisible. Under a dark sky, it will look like a smudge, a faint, ghostly thumbprint on the velvet of the night. This brings me to the most common question I receive. Professor, which telescope should I buy? Here is a truth that the telescope industry might not want me to share, but as a scientist, I care about data, not sales. Do not buy a telescope for this. Not yet. A telescope is a microscope for the sky. It takes a tiny patch of the heavens and makes it huge. But comets are diffuse, they are spread out. If you magnify them too much, you dilute the light, you lose the context. You look at the trees and miss the forest. Your best instrument is a pair of binoculars. A simple standard pair of 10x50 binoculars. Why? Because binoculars allow you to use both eyes. Our brains are wired for binocular vision. Using both eyes increases the signal to noise ratio in your brain. You actually perceive a brighter image with two eyes than with one. Furthermore, binoculars give you a wide field of view. You can scan the horizon. You can find the reference stars. If you are in a city like Boston, New York, or Chicago, you are fighting a losing battle against light pollution. I often tell my students at Harvard that light pollution is the greatest tragedy of modern astronomy. We have cut ourselves off from our cosmic heritage. If you can drive away from the city, drive an hour, find a place where you can see the Milky Way. If you can see the Milky Way, you have a good chance of seeing the comet. Now, let me walk you through the physiology of what happens when you step outside. This is something we often forget in our instant gratification culture. We expect to walk out the back door and see the universe instantly, but your biology is slow. The human eye has two types of photoreceptors, cones and rods. Cones are for color and detail in bright light. They are what you use to read a book or watch television. Rods are for low light. They are incredibly sensitive, capable of detecting a single photon, but they are chemically slow to activate. They require a protein called rhodopsin to regenerate. When you step from your lit kitchen into the dark backyard, your cones go blind and your rods are not yet ready. You are effectively blind to the cosmos for the first 10 minutes. You must wait, stand in the dark, put your phone away. The screen of your phone emits blue light, which instantly bleaches the rhodopsin and resets your night vision clock to 0. Give yourself 20, maybe 30 minutes. As your eyes adapt, the sky will change. It will deepen. Stars that were invisible will pop into existence. This is when you lift your binoculars. What will you actually see? You are looking for a fuzzy ball. It might have a greenish hue. This is fascinating chemistry. The green comes from diatomic carbon, two carbon atoms bonded together, and cyanogen. When sunlight in the ultraviolet spectrum hits these molecules, they fluoresce, they glow green. But here is the catch. This green color is usually only visible in the coma, the head of the comet. It does not survive well in the tail. And speaking of the tail, you might see two. This is where the physics of the solar system becomes visible to the naked eye. There is the dust tail, which is curved. It is made of heavier particles, the dust and grime released by the melting ice. These particles follow the comet's orbit, lagging behind, creating a curved fan. Then there is the ion tail. This is made of gas that has been ionized, stripped of electrons by the sun's ultraviolet light. This tail is straight as an arrow and points directly away from the sun, carried by the solar wind. Think about that. When you see that faint streak, you are seeing the solar wind. You are seeing the breath of the star that keeps us alive. There is, however, an element of chaos here. Comets are not Swiss watches. They are cats, they have tails, and they do exactly what they want. The nucleus of a comet is under immense stress. It is being heated from the outside while the inside remains frozen. It is spinning. It is tumbling. We have seen comets in the past, like Comet Holmes or Comet West, suddenly brightened by a factor of 1,000 in a single night. Why? Because the nucleus fractured, a pocket of gas exploded, or the structural integrity failed, exposing fresh ice to the sunlight. This is the excitement of observation. You are looking at a living chemistry experiment. You are watching a geological catastrophe happening in slow motion. If Comet SWAN decides to fragment, it could go from a binocular object to a naked eye spectacle overnight. Or it could fizzle out and fade away before it even reaches its peak. This unpredictability is a reminder that we do not control nature. We only observe it. There is a deeper philosophical point I want to make here, one that goes beyond the mechanics of orbits and magnitudes. Why do we look up? Why does it matter if you see this smudge of light? In my work with the Galileo project, searching for potential extraterrestrial technology, I am often met with skepticism. People want certainty. They want to know the answers before we even collect the data. But the beauty of science and the beauty of being human is the pursuit of the unknown. When you look at Comet SWAN, you are looking at time. That material in the nucleus has been frozen since before the Earth had oceans, since before the first single-celled organism emerged in the primordial soup. That ice contains the chemical fingerprints of the nebula that gave birth to our solar system. Some theories, including the concept of panspermia, which I find compelling, suggest that comets like this one may have delivered the ingredients for life to Earth. The water in your body, the carbon in your DNA. It is possible, perhaps even likely, that some of it arrived on a vehicle very much like Comet SWAN billions of years ago. So when you look at it through your binoculars, you are not just looking at a rock. You are looking at your ancestors. You are looking at the delivery service of the cosmos. There is a humility in this. We live on a small rock orbiting a mediocre star in a vast galaxy. We often think we are the center of the universe, the pinnacle of creation. But then a visitor comes from the dark, a reminder that the solar system is dynamic, crowded, and dangerous. I worry that we are losing our curiosity. We are becoming a civilization that looks down. We are obsessed with the metaverse, with virtual realities, with the digital constructs we have created. But the real world, the physical universe, is far more interesting than anything a computer programmer can design. The resolution is infinite. The physics are perfect. I want you to take this opportunity, not because it will change your bank account, not because it will make you famous on social media, but because it will reconnect you with reality. Go to a dark place, bring a chair, dress warmly, warmer than you think you need to, bring a warm drink, and just sit. Let your eyes adjust. Find the constellations, use a star chart, a paper one, not an app. Learn the sky, and when you finally spot that faint fuzzy glow of Comet SWAN, don't just check it off a list. Think about the journey it has taken, millions of years in the dark, falling, just to sizzle in the warmth of the sun for a few brief weeks before heading back out into the void. It is a metaphor for our own lives. We are here for a brief moment in the light. We are conscious, we can see, we can understand. There is a question that keeps me awake at night, and it is not about the comet itself, but about us. Will we continue to look up? Will we continue to fund the observatories? To teach our children the names of the stars? To wonder what else is out there? Or will we seal ourselves inside our cities and our screens, forgetting that we are crew members on a spaceship called Earth. The comet is passing, it does not care if we see it, the universe does not require our validation, but times require the universe. We need these moments of awe to remind us of our scale. So here is my advice to you. Tonight or tomorrow morning, set your alarm, wake up while the rest of the world is sleeping, step outside, feel the cold air, look to the east, and witness the visitor. It is a silent messenger from the dawn of time, and it is waiting for you to simply look up and say, I see you. Thank you.